So we're going to follow a classic margarita recipe where we need 2 ounces of tequila, 1 ounce of lime juice, and 1 ounce of triple sec. In our bar, we have 8 ounces of tequila, 6 ounces of lime juice, and 5 ounces of triple sec. And we want to know how many full margaritas we can make. So first thing we need to do is figure out the limiting reactant by figuring out how many full margaritas we can make from 8 ounces of tequila. So we start with our 8 ounces and then we multiply that by the ratio of how many ounces we need to make 1 margarita. So it's, for 1 margarita we need 2 ounces of tequila. That's our ratio. Cancel out the ounces and we're left with 4 margaritas. Next we need to figure out how many we can make from 6 ounces of lime juice. But we're going to do the same thing where we're going to start out with the 6 ounces of lime juice and then multiply it by the ratio. And for every 1 margarita, we need 1 ounce of lime juice according to the recipe. 1 to 1. And the ounces go on the bottom because they need to cancel out. Lastly, we need to figure out how many we can make with 5 ounces of triple sec. And same process again, take 5 ounces of triple sec and multiply it by the recipe ratio, which is given by 1 ounce of triple sec for 1 margarita with the ounces going on the bottom so they cancel. Next we want to look at which ingredient produced the fewest amount of margaritas, and that will tell us our limiting reactant, which in this case is tequila because it only made 4 margaritas, which is also the total amount that can be made because we don't have any more tequila, unfortunately. Next, we're going to look at a more textbook chemistry example where we have hydrogen and oxygen reacting to make H2O gas, and we need to figure out how many moles can be produced from 8 kilograms of hydrogen and 96 kilograms of oxygen. First step, we need to find the limiting reactant, and this is the exact same as the previous problem. We're going to figure out how many moles of the product, H2O, can be made from 8 kilograms of hydrogen first. So we write this as moles of H2O by H2. And you take your starting value, 8 kilograms, and then multiply that by the ratio. And first we need to get from kilograms to grams because that'll be able to link us up to moles and so on. For every 1 kilogram, there's 1,000 grams, and kilograms on the bottom to cancel. Next, we go from grams to moles. We're going to need the molar mass of hydrogen because molar mass has units of grams per mole. And it's 2 because it's H2. And that goes in the bottom, so our grams will cancel, and we're left with moles of H2. Lastly, we're going to go from moles of H2 to moles of H2O according to the coefficients in the balanced equation. And this is 2 to 2, which is equivalent to 1 to 1, but we're going to write it in the brackets so we know that we haven't missed that. And cancel the moles of H2 and we're left with H2O. And then multiply everything together, and this results in 4,000 moles of H2O produced from the hydrogen. Next, we're going to go to the other reactant and figure out how many moles of H2O can be made from 96 kilograms of oxygen. Same step as before, convert from kilograms to grams by the 1 to 1,000 ratio. Cancel the units and then multiply by the conversion ratio from the molar mass of O2, which is 2 times the molar mass of oxygen, which is equal to 32. grams per mole. And our grams go on the bottom, so they cancel, and we're left with moles of O2. Lastly, we need to multiply by the mole ratio, which in this case is 1 to 2, because there's 1 mole of O2 for every 2 moles of O2, H2O, similar to our margarita example. Cancel the units, and this results in 6,000 moles of H2O. And now we need to compare the two, and as you can see, H2 produced fewer moles of H2O, so it is our limiting reactant for this problem. And 4,000 moles is also our total for this reaction, because we don't have any more H2, just like we didn't have any more tequila, so that's the max amount that we can make. I encourage you to pause the video and try this one on your own using the techniques discussed in the video.